Welcome everybody. This is lesson 8-7 and I've got my good friend Kevin Klein who's going to help me with today's lesson, and he's really going to help too because he's already pre-read the lesson and he's up to speed on it. So we're going to be talking today about congruent and similar figures. And while we're still on this home screen, let's go ahead and get some notation down.
Okay.
So Kevin, in your reading, did you see the symbol for congruent anywhere in the lesson? I don't know if they had it. Yeah, I don't think it's in your book, so let's actually give you a little bit of head start. So the symbol for congruent looks like an equal sign, except it's got a squiggly on top. So it's three different lines, two straight ones and one squiggly. Okay, and that means congruent. And congruent, we'll talk a little bit more about it, but basically it's the geometric equivalent to equality.
Yeah.
And so two figures are congruent if they're the same what?
Same shape and size.
Right, the same shape and exactly the same size. In other words, if you took the two figures and put them on top of each other, one would completely, exactly cover up the other one.
Yeah.
Now, similar just means same shape,
Yeah.
not necessarily the same size. And the symbol for that is just a single squiggly. So these are the same squigglies you use when you're doing approximately equals to when you're rounding, but instead of having two of them, for similar you only have one. And for congruent, you put one squiggly on top of an equal sign. So that's the notation for congruent and similar figures. All right, so as we said, let's go back to congruent for a second. So congruent means same size and shape. And that's, if anybody asks you what congruent means, that's all I want you to have to say. And I can't really read that. Let me fix that. Congruent. Let's try to write a little bit slower. Congruent. There we go. All right, and there's no little apostrophe there, so let's fix that too. My stylus is not working today. All right, there we go. So congruent, and again, the symbol for congruent is this symbol right here, equals with a squiggle, and it means same
shape and size.
Same shape, same size.
Yes.
Okay, similar, which is abbreviated with a single squiggle.
Yeah.
Just means same
shape.
shape.
So
Wow, I can't spell today. Same shape. Actually, I can spell. My stylus can't spell. All right, so an example of two congruent figures, if I have a triangle like this, okay, and I want to have a congruent figure, the easiest way for me to do this
just copy it.
is actually to use the copy-paste functions.
Boop.
Okay, and so these two, and I don't know where it accidentally got the G in there. All right, so these two figures are exactly the same size and shape. And I'm not positive that this is going to work on the video, but let's go ahead and try it. So while we're recording the video, I'm actually going to move this, and if I put this over top of this one, and again, I don't know if you can see this on the video, but you can literally see that they'll pair up. So I hope that that transfers on the video. We'll find out. All right, so those are two congruent figures. Now, let's copy it down again
Two similar figures.
to similar. So let's start with the same triangle. Okay, and now
Still taking that G
I'm
with
gonna
it.
paste it again, except this time,
Expand it.
yeah, well, yeah,
Or
that's
shrink
good.
it.
Oh, it's not gonna let me do it. All right, so yeah, I'm gonna have to do this by hand.
Oh no.
Oh, we got that silly Y again, didn't we?
Y or G?
Well, it was a G. Okay, so all right, so the expanded version of this would look like this. So it's going to be the same exact triangle,
But expanded.
just expanded. And the way I can tell something similar, while the sides may change, the angle measures won't, because angle measures are what determine the shape of something.
Yeah.
So if I measured these angles here, we'd see that they're equal. I mean, it's not perfect. If I'd drawn a perfect one, it'd be perfect. But these the three angles, this one here and this one here, should both be the same.
Yep.
Okay? The double angles, this one down here and this one down here, should both be the same. And if you look at that, I think you can see that they are, in fact, the same, at least as close as I can draw freehand. They are, in fact, similar shapes. Now, Kevin and I were talking about what we can say about all squares. Now, think about squares. Think about the shape of a square. A square is a quadrilateral, for just a quick review of polygons, that has equal sides and equal angles. So they're all going to have all right angles, right?
Yep.
And all the sides are going to be the same. So what can you say, Kevin, about all squares?
They're not all of them are congruent.
They're not all congruent because they can have small squares and big squares, but what are they all going to be?
They're all going to be similar.
They're all similar because they're all the same shape, right?
Yeah.
They're all going to have four right angles, and they're all going to have equal sides. So all squares are the same shape. It's just how big they are that determines, whether or not they're congruent. So we can say that all squares are similar. We can also say all circles are similar. We can say all equilateral triangles are similar because those three objects only have one shape.
Yeah.
So the shape will always be constant. The only thing we have to determine is the size. Now, if the size is the same too, then we go a step further and we say they're congruent.
Yeah.
If the size is not the same but the shape is the same, then we say that the two figures are similar.
Yeah.
Now, there is one sneaky one. All right, so let's take a rectangle.
Yep.
Oops, I probably should use a little bit easier color to see. Okay? And maybe I'll even put a little smiley face on the rectangle.
Yeah,
All right.
it's happy.
Now, suppose I did this, and I kind of stretch it out, and I squish it down. And I keep the face on it, but the face is going to be a little bit more squished out now. All right. Now, you might look at that and think, okay, well, they're both rectangles with smiley faces, right?
Yeah.
So my question is, are they similar?
I'm going to go ahead and say yes.
Well, that would be a good guess, but that would be incorrect. And here's why.
Oh.
They're not the same shape, are they? So while they do have the same angle measure, the proportions here are different. So the long side here is only a little bit longer than this, right? But over here, look at the long side. It's
Oh.
probably like 4 times. So what's happened here is I've actually taken this figure, and as I've gone this way, I've actually stretched it this way. I've stretched it horizontally, so I've stretched it out like this, and I've compressed it vertically. So while it did start with the same shape, I've squished it in different directions. And so it's no longer, one of the interesting things about similar figures is they're going to be proportional.
Yeah.
Okay? Now, in a triangle, if I had all the same angle measures, it would be the same shape. But in a rectangle, we can have ones that are almost squares, that are pretty blocky, square-ish rectangles. We can also have we can even go on a lot further, right? We could have this as a rectangle that's totally stretched out. Okay, so again, it has to be exactly the same shape. So if I do an expansion or a contraction, everything has to expand and contract the same way.
Yeah.
Okay, so that will make similar figures. So what you're going to be doing in the classwork that you work on this lesson is you'll have, you're going to be using a lot of proportional thinking from chapter 6.
Just like this
Okay,
looks like
so
that.
when two figures are similar, so let's say figure A is similar to figure B, it means that any lengths in A are proportional
to any lengths in point in thing B.
exactly to B. Okay,
Yeah.
so for instance, suppose A is a rectangle and it's got sides of 2 and 5, and then I do a similar rectangle and I find out that the little side has gone to 4.
Double.
So I've doubled it, right?
Yeah.
So what would the side have to be here for this to be a similar figure?
This have to still be 5, wouldn't it?
No, you have to double
Oh,
that one
10.
too. So it'd have to be 10, right. If it's proportional like that, we can say that the figures are similar. That's it, guys. So congruent is same size and shape. Similar is same shape,
But not.
not necessarily the same size. However, you can't just do anything to the size. Okay, we've got to make sure that everything expands or contracts by the same ratio. Okay, so they have to stay proportional. So this is kind of cool because we're going to tie in geometry with the proportional stuff we did earlier in the year.
Got it.
Excellent. All right, that's it. Kevin, thank you very much for helping me with the video. And everybody else, thanks for watching. And this is Mr. Gunn and Mr. Klein signing off saying, see ya. Thanks for watching, guys.